doing something a little bit different. Now that we are remote, and we only have 30 minutes of class time, I still need to get through the whole lesson for today, and I don't want to just have you do one activity on your own. I only have one activity for each new learning target. So what we're going to be doing moving forward is I'm going to be pushing out to you guys videos of me actually recording and going through the second activity that you're going to be working on your own. So we're in this unit, unit 3, and we're talking about understanding proportional relationships. So we are graphing proportional relationships from a story, and we can use the constant of proportionality to compare the paces of different animals. If we remember, we said that the constant of proportionality is that constant rate of speed, right? How fast is this person walking? And we're going to compare these we compared in the first activity we did in class today, we compared the speeds of the ladybug and the ant. So in this next activity that we're going to be working on, we're going to be looking at these same two people, or well, animals really. And we're going to be throwing in another animal, and we're going to be looking at that rate of speed, and we're going to be comparing. They're going to give us a comparison to this new animal's speed and the speed of the ladybugs, and we're going to have to determine that new animal's rate of speed. So we looked at these moving ladybugs and ants, and if we remember, they had different rates of speed. And we're going to need to remember and refer back to those when we're going through. So please make sure that you have your textbook or those slides open for today. Obviously you have the slides open because you wouldn't have been able to get to this video unless you had your slides open. But we're going to be using the activity moving through representations to do this second activity here. So we went through and we found which line represented each one of these animals, how long did it take to travel 12 centimeters for the ladybug and the ants. Then we actually created this scaled graph here. Then now we're moving into the second activity here. It's actually called activity number 3 because activity 1 was our warm-up, activity 2 was the first part of this, and so now we're going to be taking a look at this next activity, moving twice as fast. Okay, so once again, I said we're going to be dealing with this ladybug and this ant again, but we're going to be throwing another insect in this time. So let's take a look at what it's asking us to do here. So it says moving twice as fast, okay? So here we go. Imagine a spider is moving twice as fast as the ladybug. On each tick mark diagram, mark the position of the spider. So over here, I actually threw some spiders on here where we can place them where they would fall in each one of these tick mark diagrams. So if we remember, the thing about these tick mark diagrams is a little bit tricky, is that when you're putting the ladybug, the insect, the ant, or the spider on this tick mark diagram, we're always going to count from the head of the insect or animal, right? So we're going to count at that the head or the front of that animal. So this guy, his head is sort of in the middle. So we're going to be we're going to be placing his distance. When we're marking his distance, we're going to be using the far right side of the box. So if he's starting at the same spot that the other guys are, he's starting in the same spot. He's starting at that start line. His front of his box is lined up with that start line. I moved him over a little bit so that he's perfectly sort of lined up. So if he's moving twice as fast as the ladybug, first, what we need to do is we need to remember back. How fast was that ladybug moving? You can sort of go back a little bit. You can also refer to it here, right? Because we went from at this starting line here to now after 2 seconds, she was 1, 2, 3, 4 centimeters from the beginning. So if I'm looking at this guy right here, and I did this when we did this in class, so I'm just going to sort of write it out on my chalkboard here. So the ladybug, if we look at it, she moved 4 centimeters for every, not 1 second, because if we look here, she actually went from 0 to 2 seconds. So our change in distance is 4 centimeters. The change in time is 2 seconds. So it's 4 centimeters for every 2 seconds, but I want to figure out how far does she go every second? So if I look at it as a fraction of 4 over 2, I can simplify that. If I want to make it 1 second, to go from 2 to 1 second, I have to divide by 2. Divide my denominators by 2. So if I divide my numerator by 2 as well, because I'm dividing by the same number here, 4 divided by 2 is going to get me 2. Think about what your label is going to be. So the ladybug moves at 2 centimeters per every 1 second. So we can write that out as like a phrase of he walks a speed of 2. Sorry, Mr. Main's markers are not working. 2 centimeters per second. Okay, and we can write that out as 2 centimeters per second. So we remember how fast the ladybug went. So the ladybug went 4 centimeters per second. So I'm just going to sort of write that on here for myself so I can remember how fast this ladybug goes. So the ladybug moves at 2 centimeters per second. Okay? So it tells me now this new insect is going to be moving twice as fast. So the new insect, or the spider, so I'm going to throw in this new guy here, the spider will be moving at 4. Because if we're thinking it's double, what do we have to do when we double a number? We multiply by 2. So if we're going 2 centimeters per second, or 2 centimeters per second for the ladybug, the spider is going to be moving at 2 times 2, which is 4 centimeters per second. Ooh, but S-E-C-O-N-D, right? But I'm looking at these tick diagrams. These actually move at, these go 2 seconds. So if I know I go 4 centimeters per second, but I need to figure out how far that I go in 2 seconds, I would have to move that distance of 4 times that by 2. So in 2 seconds, he's going to move how many tick marks? So if in 1 second he moves 4 tick marks, in 2 seconds he's going to move another 4. 4 plus 4 is 8 centimeters per 2 seconds. Just so that, S-E-C. Okay, 8 centimeters per 2 seconds. So now on this 2 second line, we're going to have to go 8 centimeters out from the start. That's 8 little tick marks. 1, 2, 3, 4, 5, 6, 7, 8. So he's right here. I'm going to grab my spider. Oh, Mr. Main, you definitely should have marked that a little bit better. 4, 5, 6, 7, 8. Very good. So at 2 seconds, he's going to have gone, 8 centimeters. Good. So then now, if I have to go 2 more seconds, so that means I went 8 plus another 8 more. 8 and 8 is 16. So I need to come back to the start and I need to count 16 out. 1, 2, 3, 4. 1 second. I'm going to grab him and count with him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's how far he's going to be after 4 seconds. Okay, so now what I want you to do, we did the first 2 together. These should be marked on your diagram as well so that you know where the spider is going to be. So now I want you to pause the video and I want you to place where he's going to be at the 6 second mark. Okay, so I want you to pause because when you come back, I'm going to go through it. But I want you to pause it. I want you to place where he's going to be, grab him off this stack here and place him where he's going to be after 6 seconds. Okay, and pause. Okay, welcome back, guys. So we know he's moving 6 seconds. So he's been moving for 6 seconds now. So we know that 6 seconds is like saying 2 times 2 or 2 plus 2 plus 2, right? So 3 groups of 2. So if he moves 8 centimeters, 8 centimeters for every 2 seconds, I can say 8 plus 8 plus 8. So 8 plus 8 plus 8 is 24. So he should be 24 tick marks from the start line after 6 seconds. Or you could say, how far is the ladybug? I need to take him twice as far. So if I start the ladybug, I know that the ladybug is 12 out. I remember back. So 12 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And look at that. He's right at the finish line. So I'm going to take my spider and I'm going to line him up with the finish line here. And the ladybug and the spider and the ant are done walking their little guys. So what you need to be doing is you need to make sure that you have your insect marked off where your spider is going to be at each one of those time frames. Make sure those are marked off before you go to the next slide. Okay, so now as we go to the next slide, it says flat the spider's position on the coordinate axis with lines U and V. Connect them to make a line. Okay, so we're gonna find some distances like we just did on that diagram. We know that at 0 seconds, time in seconds. Okay, at 0 seconds, we said how far was that spider? The spider's distance was 0. Yes, you're correct. So now what I want you to do is in this timetable here, in this little diagram, I want you to fill in. I want you to calculate what's the distance going to be for the spider after 2 seconds, 4 seconds, and 6 seconds. So I want you to pause the video and put those times in there for me. Pause. Awesome. Here we go. So we said that at 0 seconds, he was going to be 0 centimeters because he started at the starting line, right? So then after 2 seconds, his was double the ladybug. And we knew that the ladybug moved 4 centimeters per every 2 seconds. So if we double that, he's going to be 8 centimeters away from the starting line. And I'm going to come back up here and I'm going to give this a label of centimeters as well. And then we said 4. So 8 and then another 8 more. 8 and 8 is 16 centimeters from that start line. And then we said it was going to be 3 groups of 8 now because every 2 seconds he moves 8 and 6 seconds is made up of 3 2s. So it's 8 plus 8 plus 8, which we know our multiplication, 8 times 3 is going to get us 24 centimeters. Awesome. So now we need to take these points here, oh my goodness, and we need to plot them on our graph on the next slide. So my suggestion, what I'm doing is, you can easily flip back and forth between these 2 slides. That's completely fine. I'm just writing them down for myself so that I don't have to keep flipping back and forth. So I'm just writing down 0, 8, 16, and 24 centimeters. I just wrote it like this, not a big deal. So now I'm going to come to my next point here, this guy over here. So we know that after 2 seconds, the distance so that when we went 2 seconds, this new guy is going to be, we have our first point is going to be at 0, 0. So 0 seconds, we're at 0 second, at 0 centimeters. So I'm going to put the point right there. It's kind of a little bit big, but it's okay. Then we know after 2 seconds, he traveled 8 centimeters. So we're going to go up to a lapse time of 2 seconds over to a distance that we found in our table is going to be 8 centimeters. So I'm going to put my point on up to over to the 8, and I'm going to connect them. Okay? Then we also know after 4 seconds, if we look at that table, it was going to be 16 centimeters from that initial starting distance. So I'm going to go up to 4 over to 16, and I'm going to put a point there. Okay, so then now, remember, we want to now, we have these points plotted. So now we need to grab a line segment and we need to connect these points. So that means you're going to come up into so you put these on yours as well. Okay, so these points should be now plotted on here. I want you to pause your video. Actually, no, I'm not going to have you pause your video. I'm going to have you grab this little line feature right here. And I'm going to have you click this little line feature right here. And I'm going to have you put it right on that point at the 0, 0. I don't know why that just happened. So once again, I'm going to have you click the line feature. Click on this little point at 0, 0. Make sure that it goes through your other 2 points that you plotted here, like this. I'm going to come over here. I'm going to make the line a little bit darker. So right next to this little pencil, you're going to click on the little 3 lines. And I'm going to change it to 3. And I'm going to change the color to orange so that I can see it really well. Okay, so I plotted this line on my graph. You also need to plot this line on your graph. Okay, because we just plotted this guy here. And we have the line of our ladybug and the line of our ant. And now we have this line right here, which represents which animal? Our spider. Exactly. Our spider. So we just plotted, kind of crazy, we just plotted this equation for this new spider right here. So once you have it, if you need to pause the video right now, you can, to connect your points, make sure they're on there, because I'm going to be checking back to make sure that these slides are done. Awesome job. Let's take a look at this next slide here. So pause if you need to, and then once you play it, we're going to be moving on to slide number 13. So now, here comes the tricky part, okay? So we just created the equation. We just created the lines. We just put our new animal on the tick diagram. Now, our last piece for this activity is we need to write an equation for each of the 3 lines. So remember that we use this form of y equals mx, right? And m is our constant rate of change, and y and x are our our y and our x are just those variables, right? So that y is going to be the time elapsed, right? So when we look at it, it's going to be y equals mx. And when we're writing equations, you want to write them, the m being that constant rate of change. So that speed at which we're walking. So our constant rate of change. I like to call it a croc. I know. Kind of silly. I know. It sounds kind of silly. But it's a croc. Constant rate of change. So once we're creating those equations, I want you to actually try to pause the video right now. And I want you to try to create an equation. I want you to take 5 whole minutes, or I want you to take 3 whole minutes. I'm going to put a little timer at the bottom of this slide here, and you're going to start that timer for 3 minutes. You're going to only take that 3 minutes. Don't push yourself any further than that. And then you're going to play the video back, and we're going to go through those 3 equations, okay? So hit pause and try to write an equation for each one of these 3 different animals. And wonderful. Okay, so guys, I know that was super duper challenging, and I know that we haven't really had much experience with writing equations, so we're going to take this one step at a time. So when we're talking about writing equations, we use this form y equals mx, and m is that constant rate of change. So let's go back and let's do this ladybug. Because remember, we talked about how fast she was moving every second. If we go back to this little slide right here, and we think back, how fast did the ladybug move every second? We were able to calculate that by saying that after 2 seconds, she moved 4 centimeters. So after every 1 second, she only moved 2 centimeters. So you could also look back at this graph right here, where you could say after 1 second, how far did that ladybug move? She moved 2 centimeters. So if I look back and write an equation for this ladybug, I'm now going to be using that form y equals mx, right? And m meaning that constant rate of change, that y and that x are just going to stay the same. We need 2 variables when we're writing an equation. So we're going to say y is equal to, her constant rate of change was 2 centimeters per second. So it's going to be 2 times x. Okay, so you could have also written it as y equals 2x. Those both mean the same thing. I just put this little symbol in here to remind you that when you have a number attached to a variable like this, or a letter, that means they're connected and there's no sign in between them. If there's no sign, it's automatically, you can assume that it's going to be multiplication. Okay, so now we need to think back to this spider guy. So we think back to this spider guy. His equation, his speed was double hers, right? So we could say y is equal to, and then her speed, the ladybug's was 2, and we say his is double. So 2 times 2 gets me a constant rate of 4 times x. Or you could have written it as y equals 4x. So now we need to think back. Haven't talked about in this video. We haven't talked about the spider's rate of change yet. I mean the ant's rate of change yet. So we need to look back at this graph here to figure out how fast is that ant moving. So remember, we said this ant is this line V here. So if we look at this line V after 1 second, the line V is moving. Ooh, it falls between 2 and 4. Ooh, 2, 4, ooh, 3. Yes, that constant rate of change is going to be 3. So the ant's equation is going to be written as, what's it going to be? Tell me. Yes, it's going to be y is equal to, and let me just do some spaces here so that we can see this a little bit better. Y is equal to his constant rate of change, which is 3 times x. X being that, X being the distance that they traveled, and then that y is going to be equal to that elapsed time. So remember, we said we could write it as y is equal to 3 times x, or we could also write it as y is equal to just 3x. Okay? We're going to be doing a lot more work with these moving forward, so don't feel stressed if this was a little bit challenging. But awesome job. So let's take a look at this last few pieces here. Okay. So it says, remember, line U is the ladybug line. Line V is the ant line. So now I want you to plot a bug that is 3 times as quick as the ladybug. So 3 times that constant. So the ladybug, remember, goes 2 every second. So, if we plot one that goes 3 times as fast, that's going to take that initial distance of 2, multiply that by 3. So in 1 second, he's going to be able to go 6 centimeters. He's going to start at that same spot of 0, 0. And then after 2 seconds, he's going to have gone, 6 times 2 is going to get me 12. Oh my goodness. And then I can take my line here, and I can connect those points again. Oh my goodness. What are we noticing as we look at this, guys? What do we notice? When we draw in this animal now that's moving at 3 times the speed of the ladybug, what's happening to our line here? So before, hers wasn't too steep, right? I mean, it wasn't the steepest, right? I mean, it was probably the steepest of the 3. I'm sorry, Mr. Me. It's a goofball. So then as we're moving on, and once these guys are getting faster, these lines are actually not getting steeper. They're getting less steep. It's kind of crazy. Okay, let's look at the last piece here. Okay, so if you have to pause to do that, you can. Let's take a look at slide number 15. Okay, this is the last bit before we get moving on to this exit ticket, okay? So it says, remember, line U is the ladybug and V is the ant. What would be an equation showing the relationship between the bug's distance and the times look like? So if we're looking back to this new guy that we just plotted here, this guy's here. Now, what's his equation going to be? Remember, we use that form of y equals mx, right? So let me write that in here. Y equals mx. And I want you to take literally 30 seconds. Pause and go 30 seconds and see if you can write the equation for this guy here. I think you can, because we're just talking about finding that constant rate of change here. How fast is he moving every second? And we can go back and recalculate that if you have to. Look back at the graph if you need to. Okay, pause. And here we go. So this new guy, we're going to call him a possum because possums are much bigger and they can move much faster than ants and ladybugs. So this is going to be a little possum, my possum Eddie. And I want to write an equation for how fast my possum Eddie is moving. He moves at a speed of, when I'm writing an equation, y is equal to, and now let's look back at his speed, because every second he moves 6. So his rate of speed is going to be 6 times x. So it's going to be y is equal to, yes, you got that. Yes, you got it. 6x. Simple, not too bad. We're just plugging in that rate of change for every one of those boxes. Okay? So, oh my goodness, ladies and gentlemen, you guys are rock stars. I know this video is a little bit long, and I know I had you stop and I had to do a few things, but you guys are fantastic, and I'm so proud of you. And before I have you go, I'm going to show you something, and I want you to send me an email with this in it. So this weekend, I made myself some fuse beads, and I made C3PO. So the magic code phrase for this video is going to be C3PO. So send me an email. Open it up right now. Send me an email with the word C3PO. Okay? Boom. It's code phrase. Last thing I want you to do is sort of like your exit ticket for today. So now I want you to take your time. I want you to, this graph represents the position of 2 turtles in a race. Plot points to show another third turtle that's going half as fast as the line G. So now after 1 second, he's only going half the distance. So think about what's going to happen to that line. I want you to use these points to make, to plot some points, and then grab your line tool and connect them like we did in our video before. Okay, so you're going to take one of these points. He's going half as fast. I don't know where he's going to be. Might be there. Who knows? Because after 1 second, this guy G is going 2 centimeters. So if he's going half as fast, his distance is only going to be half as far on 1 centimeter. And then you're going to keep plotting them, connect them using your line feature, and then you will be all set. Once you finish this guy right here, I want you to hit the turn in button and make sure that I get this from you for the day. Guys, I know this was a little bit long, and I know it was a little bit crazy, and I probably shouldn't have gone this long. But I have a feeling that you guys are going to do fantastic with this. So send me emails. I'm going to be here if you need me. And have a great day. I will see you tomorrow. Please don't forget to email me C3PO, okay? Yeah. Bye, guys.